Hello everyone, this lesson is about rates of change. So by the end of this lesson, you should be able to use the slope formula to find the rate of change for things in real life, because we actually see rate of change all the time. So slope as a rate of change is basically just a way to represent slopes found in real life. It describes how much the vertical changes with respect to each unit change horizontally. Remember from last lesson that the slope is the change in the y value, so the vertical, divided by the change in the x value, so the horizontal. When we're talking about real life situations, a common unit that you'll see is time. And it's important to know that time is almost always on the x-axis, so make sure to make time your x-coordinate. Here we have a graph showing us the distance Rick is from a motion detector and the time it takes him to be at that distance. So just like any other slope calculation, we're going to be calculating rise over run. So I've written our sort of basic formula here, rise over run, or vertical change over horizontal change. You might notice these little triangles. The triangles are actually the Greek letter delta, and what that symbolizes is change. So if you see those in any notes or anytime you're reading about math, that's sort of what the delta or the triangle symbol means. And so what I've written down is the formula of y2 minus y1 over x2 minus x1. Now, looking at the graph, I want to find 2 points on my graph that line up pretty perfectly with the cross section. And the first point that I picked is at x, 0, y, and the second point I picked was at x is 10 and y is 4. So I'm going to go ahead and plug those into my formula. And let's make this blue dot my y2. So my y there is 4, and I'm going to be dividing that by the 10. So I've written in my y value for my first point, and they're both going to be subtracted, and my red point is going to be my x1 and y1 values, and my y1 is 8 and my x is 0. So 4 minus 8 is negative 4 divided by 10, and that is our slope. Except notice that they're both divisible by the number 2, so we need to reduce that slope to be negative 2 over 5. You'll notice, though, that the question asks, how fast does he walk? It doesn't ask for the slope, it's how fast does he walk. So we need to make sense of this slope. And to do that, we need to use the units. So our slope here is negative 2 over 5. And remember, our rise is our distance. So our unit is meters, and our run is our x, and so our unit is seconds. Now there's a few different components to dissect here. We have our negative, we have our numbers, and we have our units. Let's first talk about our numbers and units. Another way of representing these numbers, of course, is as a decimal, which would be 0.4, and our units are still there, so they're meters per second. So basically, we can say that Rick walks 0.4 meters per second. We could also say that he walks 2/5 of a meter per second. And finally, you could say that he walks 2 meters every 5 seconds. Now the last component I want to discuss is this negative symbol. So this negative symbol tells us a bit about the direction that Rick is moving. We can't exactly say if it's forwards or backwards because that's all sort of relative. What we can do is look at our graph because our graph tells us a lot of information. At time 0, he is 8 meters away from the motion detector. At time 16, he looks to be about, 1.5 meters away from the motion detector. So what this tells us is he is walking towards the motion detector. And so if we recall our original question, it was, how fast does he walk? Well, if the slope is 2/5, Rick is walking at a pace of 0.5 meters per second. In this graph, we have Laura and her income on the y-axis and time on the x-axis. Notice in both cases, time is on the x-axis. So the question is to determine the rate of change for Laura's income time graph. Well, we know rate of change is just another way of saying slope, so I wrote down our slope formula, and I'm going to pick 2 points on the graph. Let's go with maybe 0, 0, and how about 2 and 150. So what I've done is I have put in my values. So my y1, x1 are 0, 0, so here they are in red. And my second point is, oops, I've made a mistake there, so I'll just need to swap those around. So my y is 150 over 2. So obviously 150 minus 0 is 150, and 2 minus 0 is 2. So if we take 150 divided by 2, we get 75. You may notice that there are lots of different points that you can use along this line. You may also notice that I did not pick the easiest points. The easiest points may have been 75 over 1, because then that just means that our slope would be 75. So there's lots of different ways you can do this, or points you can pick. Now, we know that it's income over time. So that 75 is not just a rate of change all on its own. It is dollars per hour. So I've just done a little bit of a conclusion sentence saying the rate of change for Laura is $75 per hour, which basically is saying she gets paid $75 for every hour she works. Okay, in this new problem we have Wile E. Coyote standing on top of a cliff 500 meters above ground. So whenever we have a math problem that involves some imagery, I like to draw it out personally. So there I've drawn him on the left. I guess I could give him some little legs. And then it says he was tricked off the cliff 5 seconds later and now is at 100 meters. So, maybe he's down here now, and that's 100 meters. And it took him 5 seconds to get there. So that's one way to imagine it, and you could also draw a little graph if you wanted to. So I'm drawing his little graph. He started out at 500 meters at 0 seconds, and then he moved to 100 meters, and he got there after 5 seconds. So that is our slope right there. Now, 2 ways to sort of imagine the problem. The graph is easier in terms of figuring out or plugging it into our formula. So in this case, our y2 is his end height, which is 100 meters, and our y1 is our start height, which is 500 meters. Our x2 is 5, and our x1 is 0 seconds, because that's sort of the start of the story. And if we follow along with our calculations, that gives us negative 400 over 5, which is negative 80. And again, we know that our units are meters per second. So we also have that pesky negative sign telling us that he is going in some direction. In this case, looking at our graph or even our diagram, we can tell that he's going down. So in this case, our negative means he's going down. And so there are many ways that you can sort of describe this in words, but what I'm going to say is Wile E. Coyote ran down the cliff at a rate of 80 meters per second. So the only thing left for you to do is check out your homework. It is on the hub as always. Good luck and have a good week.